Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 5 lectures, right? So in a previous lecture that we have discussed about some of the selected problems based on parallelogram law of vectors and its applications, right? I hope that you all enjoyed that lecture. So in today's lecture that we are going to discuss about addition of more than two vectors, addition of more than two vectors. It is also called as a polygon law of vector addition. Okay, and some examples. Also, we are going to discuss about laws of vector addition. Okay, so these things that we are going to discuss in this session, right? So my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Right. So what is the chapter going on? What is the chapter going on, ma? Motion in a plane. Motion in a plane. Okay. So this is a class number 06. Okay. What is today's topic? And today's topic is what? Addition of more than two vectors. Addition of more than two vectors. And this is also called as a polygon law. This is also called as polygon law. Okay, so let us see the statement of polygon law of vector addition or addition of more than two vectors. Have a look the statement. If some vectors, if some vectors are represents the sides of a polygon, the sides of a polygon taken in order, taken in order, and then their result, then their result is given by, then their result is given by the closing side of the polygon, the closing side of a polygon taken in reverse order, taken in reverse order. Are you getting now? So what is the statement of polygon law of vector addition? So if some vectors are represents the sides of a polygon, if some vectors are represents the sides of a polygon are taken in order, we know how to take the vectors in order. So one head of the vector is attached to tail of the next vector. Likewise, we have to take the vectors in order. And if you want to find their resultant, and if you want to find their resultant, then the resultant of these vectors is given by the closing side of a polygon taken in reverse order. So if you want to find the resultant, then you have to close the polygon and whatever the closing vector is there, and you must and should take that vector in reverse order. Have a look. If the vectors are like this, so this is a bar vector, okay, and this is a b bar vector, this is a c bar vector, okay, and d bar vector is like this. Find the resultant vector. R bar is equals to how much? Okay, I'm going to find the resultant vector by using polygon law of vectors. Have a look. As we know the concept of parallel shifting of the vector. So what is the meaning of parallel shifting of vectors? Whenever the vector is displaced parallel to itself, its direction and magnitude never changes. Have a look. This is a bar vector. I'm just taking the a bar vector, okay, and this is a b bar vector. I'm applying the concept of parallel shifting of vectors. Okay, so this b bar vector is shifted parallel to itself, okay, is shifted parallel to itself and it becomes like this, and its direction and the magnitude never changes. Okay, so in case of c, again I'm using the parallel shifting of vectors concept and I'm shifting the c bar vector like this. I'm shifting the c bar vector like this. Have a look. its magnitude and direction never changes. So this is what? This is a C bar vector. Okay. So C bar vector, I'm shifted. Next D bar vector is there. Now I'm shifting the D bar vector. I'm shifting the D bar vector. So its direction and the magnitude is never changes. So A, B, C, D. And if you want to find resultant vector, so the closing side of this polygon taken in reverse order gives the resultant of these vectors. I'm just taking the vector in reverse order. Vector in reverse order, and it gives what resultant of these vectors. Okay, so this is the closing side, and I'm taken in reverse order. This is the meaning of vectors taken in order. Already we have discussed. Have a look. This is the A bar vector, B bar vector, C bar vector, D bar vector. Head, tail, head, tail, head, tail. Okay, now all these vectors in order. So with respect to D bar vector, so the R bar vector is in reverse order. Have a look. Head, head, tail, tail. Now this closing vector R bar in reverse order, and it gives what resultant of remaining vectors. Therefore, we can write R bar is equals to A bar plus B bar plus C bar plus D bar. So this is called a polygon law of vector addition. Are you getting it? So what is the polygon law of vector addition? If the vectors are taken in order as to represent the sides of a polygon taken in order. Okay. So if you wanted to find the resultant, so the closing vector must take in reverse order. Then it gives what resultant of remaining vectors. Is it clear? Any doubts? Okay. Have a look. One note is there. So note number 1. So the note number 1 is, if the closing side of a polygon, the closing side of a polygon is also in order. Is also in order. That means, have a look. This is A bar vector, and this is B bar vector, and this is C bar vector, D bar vector. So here resultant vector is in opposite order, but here I am taking the closing side of a polygon in order. That means I am taking the closing vector is also in order. Have a look. Head, tail, head, tail, head, tail, head, tail. So I am taking the closing vector is also in order. Let us say this is a E bar vector. Okay. So if the closing side of a polygon is also in order, then their resultant is a null vector. Is a null vector. Therefore, the resultant of the polygon is given by A bar plus B bar plus C bar plus D bar plus E bar is equals to how much resultant? Null vector 0 bar. Are you getting? Any doubt? Right. So this is about a polygon law of vector addition. Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us see note number 2. Note number 02. So the note number 02 is, if small n number of coplanar vectors having equal magnitudes and are separated at equal angles, then their resultant is equals to 0. Then their resultant is equals to 0. So we know that. What is the meaning of coplanar vectors? If the vectors are lying in a same plane, then such type of vectors is called what? Coplanar vectors. So if the coplanar vectors are having the equal magnitude, all the coplanar vectors are having equal magnitudes and are separated at a equal angle, and the angles between all the coplanar vectors is also equal, then the resultant vector is equals to how much, ma? 0. Okay, are you getting? Right. So let us see one example problem. Example number 1. Okay. So they are given diagram like this. AB, BC, CD, okay, and AD. This is not a vector. Okay, this is not a vector, this is a straight line. So AB is a vector, BC is a vector, and CD is a vector. So the AC vector is given like this. So this is AC, okay, and the BD vector is also given. So this is BD diagonals. So these are what? Diagonals. So they are asking prove that AC plus AC plus BD is equals to 2BC. AC plus BD is equals to 2BC. We have to prove this. Okay, right. So pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. I'm going to solve the solution. So what they are asking, AC plus BD is equals to 2BC. So let us consider this is a LHS. This is what? RHS. So I'm taking LHS. What is LHS? AC plus BD. Okay. So from the diagram, from the given diagram, what is AC? Have a look. The diagram is like this. A, B, C. So A, B, B, C. These two are in order. AC is in reverse order. AC is in reverse order. According to Polygon law of vector addition, the two vectors are in order. And if you want to find the resultant, then the resultant vector is must be in a reverse order, or the closing side is must be in a reverse order. Have a look. These two are in order. And just writing like this: AB plus BC, because these two are in order, and the closing side is in reverse order, and that gives what? Resultant of those two vectors. Are you getting? Right. So now AC is nothing but what, ma? AB plus BC. So AB plus BC plus BD. What is BD? Have a look. This is BD. I'm just drawing the diagram. Okay. So what is this? B, D, and this is what? BC, CD. Have a look. B, C, C, D in order. B, C, C, D in order. Then B, C plus C, D is equals. Have a look. With respect to DC, this BD is in reverse order. Closing side is in reverse order. Have a look. BC, CD in order. Okay. And BD is in reverse order. Therefore, the closing side gives the resultant of these two vectors. That is what, ma? BD. Are you getting? So now BD is equals to how much? BC plus CD. BC plus CD. Okay. Any doubts? Right. So AB plus BC plus BC. 2BC plus CD plus CD. Have a look. From this figure, it is clear that so AB is in this direction. This is what? Direction of AB. CD. Have a look. This is the direction of CD. So these two vectors are having the equal magnitudes but opposite in direction. AB is in this direction and CD is in this direction. Their direction is opposite but equal in magnitude. Then we can write AB is equals to minus CD. AB is equals to minus CD. Just substitute here. You will get AB plus 2BC CD. CD is equals to how much, ma'am? Minus AB. Minus AB. If you send minus to this side, it becomes what, ma'am? CD is equals to minus AB. CD is equals to minus AB. And just substituted. So plus AB minus AB cancel out and you will get 2BC. So AC plus BD is equals to how much, ma'am? 2BC. Hence proved. Are you getting? Any doubts? Right. So let us solve one more example. Example number 2. So at this time they are given hexagon. Hexagon given. Okay. Right. So they are given hexagon. Have a look. So this is AB, DC, CD, DE, and this is taken in reverse order. Okay. This is A, B, C, D, E, F. A, B, C, D, E, F. Okay. And the center of the hexagon is O. Center of the hexagon is O. Okay, so this is AC, and this is AD vector. This is the center O or origin O. Okay, this is AE. Okay, and this is AF. So the question is, have a look. A regular hexagon A, B, C, D, E, F with a center or origin O is given. They are given a regular hexagon with center O. Find AB, AC, AD, AE, AF is equals to how much? So this is a given question. So a regular hexagon is given, okay, and these are the diagonals AB, AD, AE. So with center O. So what they are asking? They are asking to find AB plus AC plus AD plus AE plus AF is equals to how much? So pause the video and try the solution. So use the Polygon law of vector addition. You will get the answer. Okay. So pause the video and try the solution. 3, 2, 1, go. I'm going to solve the solution. Have a look. The solution. So what they are asking? AB plus AC plus AD plus AE plus AF is equals to how much? I'm just taking AB as AB plus AC. Have a look. AC. So what is AC from this diagram? So AC is nothing but, have a look. AB, BC, AC. Same diagram we have. Okay, here we have the same diagram. So these two are in order. AC is in reverse order. Then we can write AB plus BC is equals to AC. AB plus BC. So this is what ma? AC. AC is nothing but what? AB plus BC. And AD is nothing but AD only. I'm just taking AD as AD plus. Here we have AE. So from the diagram, what is AE? So here we have AE. Have a look. AD and DE. AD and DE are in order and AE is in reverse order. Therefore, AE is equals to, we can write AD plus DE. AE is equals to how much ma? AD plus DE. AE is nothing but what? AD plus DE. Are you getting? Any difficulties there? Plus AF. Have a look. This is AF. So this AF is equals to, have a look. Again, AD, DE, EF. Are you getting? So AD, DE, EF are in order and AF is in reverse order. Then AF is equals to, we can write AD, DE, EF. AF is equals to what ma? AF is equals to AD plus AD plus DE, AD, DE, EF. Are you getting? Any doubt? I'm just using the Polygon law of vector addition. Okay. So practice once, you can understand easily. So from figure it is clear that AB, the side AB and DE. Have a look. This is AB and this is DE. So both are having the same magnitude and in opposite direction. Then we can write AB is equals to minus DE. AB is equals to minus DE. And BC and EF. Have a look. This is the direction of BC and EF. This is the direction of EF. Having the same magnitude and are in opposite direction. Then we can write BC is equals to minus EF. BC is equals to minus EF. So have a look. AB is nothing but what? Minus DE. So AB and DE are get cancelled out because if you substitute at the place of DE is equals to minus AB. Here plus AB is there, here minus AB is there. So both are get cancelled out. Okay. Next BC is equals to minus EF. So EF, BC both are get cancelled out. And again here AB is there and DE is there. Both are get cancelled out. Okay. Any other terms? Here AD, AD, AD. So finally we got 3AD. Finally we got how much? 3AD. So this is our answer. So what is the answer ma? 3AD. Okay. So here AD is there, here AD is there, here AD is there. So remaining terms are get cancelled out. Okay. Are you getting? So same thing. Same thing. Here I am doing by using Polygon law of vectors. Okay, right. So this AD, have a look from figure. AD, this is a line AD. Okay, so this is what center O. Then we can write AD is equals to AO plus OD. Can I write like this? Have a look. This is AD and this is a center point. It is at a mid of the line AD. So then we can write AO is equals to OD. Then AO is equals to OD. So if you substitute AO is equals to OD, then you will get finally AD is equals to AO plus AO. You will get 2AO. AO plus AO is equals to how much more? 2AO. Are you getting? So this is a line AD. This is a center point O. Then OD line is equals to AO plus OD. This point is at a center. Then it divides this line into equal parts. Then AO is equals to OD. AO is equals to OD. AO is nothing but what? OD. Or OD is nothing but what? AO. I'm just taking OD as AO. OD as AO. AO plus AO. 2AO. AD is nothing but what? 2AO. Then we get 3 into AD is equals to how much? 2 into AO. So 2 3 is 6 AO. This is also your answer. Or if you substitute AO is equals to OD, then you will get 2 OD. 2 3 is 6 OD. Maybe the answer is 6 OD or 6 AO or 3 AD, whatever it is. Okay, right. So pause the video and write the solution. Are you understood? Just to practice, you will get. Okay, so pause the video and write the solution. 3 2 1 go. So the last concept of today's session is a laws of vector addition. Okay, so what is that? Laws of vector addition. Right, so the first law, the first one is vector addition obeys commutative law. That means commutative law means what? So a bar plus b bar is equals to b bar plus a bar. So the vector addition obeys commutative law. Okay, second one, the vector addition obeys associative law. So associative law means if you add the vectors like this, then you will get the same answer. So both are same. Okay, so this is called associative law. So third one, vector addition obeys distributive law. That means into a bar plus b bar is there, then it can obey distributive law. That means k into a bar plus k into b bar. So this is called a distributive law. So k into a bar plus k into b bar, you will get the same answer, where k is constant. Where k is what? Constant. Okay, so these are the laws of vector addition. Okay, so pause the video and write the notes. 3 2 1 go. Right, so this is the end of the today's lecture, and we will meet on a next lecture. This is a small concept. I hope that you are understood the Polygon law of vector addition. Okay, right, so we will meet on a next lecture. Until then, keep studying and keep watching my videos. Okay, right, so this is Rakesh signing off. Jai Hind.